My name is Łukasz Rosłonek. I live in Warsaw, Poland, where I work in Allegro as a senior engineer. Besides Allegro, I also do a lot of technical writing, mainly in the area of test automation, DevOps, and let's say technical testing. You can check some of my stuff at my blog, which is testdetective.com. And I'm quite an active lecturer and public speaker, again, in the area of test automation and DevOps. So if you want to ask me any questions, or if you want to just stay in touch with me, which is my Twitter handle and email address. Okay, so let's start. So testing in production, in general, has a very bad reputation, right? And it's connected with this infamous approach of omitting testing stages, omitting stages prior to production, and just deploying our changes directly to production environment and letting our users test our software, right? And just to be clear, this is obviously not the idea I want to discuss today. Testing before production, testing in the stages prior to production is very important, is crucial for our process, and should be done whenever possible. So then, why do we even talk about testing in production environment? So there are a few problems to be considered, and especially you need to consider those problems if you are working with distributed architecture. And in terms of modern web-based systems, distributed architecture is actually becoming a new industry standard. So what are those challenges? First of all, let's talk about your architecture complexity and how you replicate this complexity from production environments to multiple test environments. So if you are working with this kind of architecture, so let's say quite simple, self-efficient application, and in some cases you can also call it monolithic architecture. And this is not a good example. So creating environments, test environments, based on this kind of architecture is rather simple and not demanding, and those environments tend to be quite stable and easy to maintain. But the situation is looking much more different when it comes to distributed architecture. Here we are dealing with tens or hundreds of independent services, and those services communicate through HTTP protocol, which gives you this another networking layer. Now, creating and maintaining those kinds of environments is not only much more harder, but it's also simply more expensive. And this is yet a very easy example of distributed architecture, because in terms of complex systems, your architecture diagrams will look much more like this. Those are the architecture diagrams from Amazon and Netflix generated by their monitoring tools. And each of those little dots in those big spheres refers to single independent microservice, each having its own infrastructure, servers, databases, and so on. Now try to imagine recreating this enormous architecture from production environment to multiple test environments. Now keep in mind also that if you create ideal copies of production environment, and this is actually our goal with creating test environments, right? You'll have to also include things as distribution of your data centers, databases replication, or even networking condition. So creating those kind of environments and maintaining them is extremely demanding. And it actually gets down to the point that the more complex and distributed your architecture is, the less stable and hard to maintain your environments, test environments tend to be. And in case of software testing and test automation, that leads you to test flakiness and false positive results. So let's talk about application versioning of distributed system right now. So one of the biggest advantages of microservice architecture is independent deployment. With this independent deployment, we can push code to production faster, so therefore deliver new features to our production users faster. So for example, if team A owns a microservice which is integrated with few services from team B, if team A wants to push new changes to production, they don't have to tell anything to team B. I don't even have to inform about anything or wait for anything from team B, as long as the REST API contract is not broken and stable. But as we all know, with great power comes great responsibility. So let's talk functional testing for a moment. If team A wants to run their functional tests before deployment, against which versions of those dependent services should team A run their tests? Against those versions that are currently in production environment, because that would make sense, right? Because our destination is production environment. Well, now keep in mind that we have these independent deployments, and we have development branches, feature branches of those dependent services. So the changes that are currently on feature branches, development branches of those dependent services can be deployed in any moment, can turn to new release in any moment independently to production environment. So we have this whole versioning confusion, and we have some tools to deal with these problems, and contract-driven testing can be one of them. But again, it gets down to the point that in case of complex distributed system, in single particular snapshot of time, the only source of truth when it comes to your versioning of your distributed system is production environment. Let's think now, what do you really know about your end users' behavior? So in case of most teams, projects, companies, you have some kind of test case repository, use case repository. Those can be written in BDD notation, which is great and very popular right now. Can be stored together with the application code, or can be even fully automated. Now, as we all know as a test engineers that running those test suites and executing those tests before the release is a tremendous thing, and it's very helpful because it oftentimes can help to prevent many defects from being pushed to production environment. But then let's think for a moment, what are those scenarios? So those are the scenarios that we predicted, that we defined, that we predicted, and we expect them sooner or later to be executed by our production users. But the problem is, if your system is used by millions of users, you simply cannot predict every single possible way your users will interact with your system in production. And if you want to somehow predict every single possible way, you would also need to include things as fragmentation of devices, many different operation systems available, or even different time zones. Now, I think a quite nice metaphor for it, or at least I hope right now it's a nice metaphor, is taking your driving license. So while taking your driving license, you are going through theory exam, and you are going through many different potential situations that can happen to you on the real roads. So it's very important to go through this theory exam to be prepared for those situations. But the problem is, once you pass your driving license and you are now becoming a part of this everyday road rage, things are looking much more different. And you simply cannot predict every single possible situation that can happen to you on the real roads. The same way as you cannot predict every single possible situation that user can interact with your system. And last thing is getting real users' feedback. So there's a tendency among engineers, test engineers, to treat development process as gathering requirements, implementation, testing, then we are pushing code to production and starting whole cycle all over again. We need to remember that our ultimate goal is to deliver some features to production environments. So therefore, production is this most important environment. And only by getting feedback from production environment, only by going through production logs, metrics, studying production monitoring, we can learn whether our production system is well designed, is defect-free, is in high quality, and whether simply our users like it or not. So production is this ultimate source of application feedback. And lately, very popular approach is shift left. And the idea of this approach is to push our quality efforts earlier to the development process. It's a great approach, but there's still one puzzle missing. And this is getting feedback from the quality feedback from our production environment. So what I would like to propose to you today in this talk is combining those two approaches of shift left and also including production environment, so shifting right, and in the result, we have this complete quality process throughout every stage of our development lifecycle. So now that we have this blurred idea about why we would want to test your software in production environment, let's discuss some various techniques to do so. And one of the best known approaches, of course, CANARY testing, also with CANARY deployment. Now, idea behind CANARY deployment is straightforward. Let's say you have a current stable version of your application in production environment, and you came up with this new, let's call it experimental version, that you already tested in test environment, or you already reviewed it, but somehow you are not so fully confident to push it yet to full production traffic. So you keep both those versions in production environment, this current stable and this new experimental one. Then you route only small portion of the traffic to this new experimental version, and you keep the majority of the traffic to this current stable version. And by doing so, you are already getting feedback from production, from this new experimental version from production environment. You are already able to go through production logs and metrics. But you are minimizing the potential risk of defects that can be caused by this new experimental version in production environment. And as for the examples, does anybody of you knows what's the connection between those two pictures in the slide? So Facebook is well known for their engineering technology, and Facebook test engineers test extensively during every stage of development process. But also in case of every new major feature, they test it in production environments on production users, but those users groups are always limited to some specific location. And for some reason, one of the mostly used CANARY testing locations for Facebook is New Zealand, where the Lord of the Rings was shot. So we all know like it button in Facebook. And there was a debate some time ago whether Facebook should include also dislike button on their page. So Facebook came up with this feature. They implemented, they tested, reviewed it, and they pushed it to production environment, but it was available only in New Zealand, so only people in New Zealand could see it and could use it. Then Facebook gathered feedback after some times, analyzed some logs, some metrics, maybe some defect reports, and decided whether to keep it or not. And as we all know, there's currently no dislike button in Facebook, so I guess test didn't go so well. So I came from Poland, and actually Poland was also such a test group for CANARY testing for Facebook. So if you're using a Messenger app, you are for sure aware of those little Messenger stories on the top of the screen. And this feature was firstly available only in Poland. Then Facebook gathered feedback from Poland, analyzed it, maybe improved something, and now this feature is available worldwide. So the subgroup of CANARY approach, CANARY testing, is A/B testing, which lets you to execute experiments in production environments with your graphic user interface. And a great example of A/B test was done by EA Sports on their shopping site. So there was this big banner on the product page informing about current hot deals. And somebody thought, maybe if we took this banner off so that the users will see only the actions directly connected with buying an item, so the conversion rate would be higher. So EA Sports ran the CANARY tests, and the results were exceptional because the conversion rate in the version without the banner went up by almost 50%. My favorite example of CANARY approach and A/B test was done by Amazon in their vehicles department. So in this department, there's this section on the page where you can choose the body type of the car you want to buy. And originally, all those body types were in shades of gray. Then somebody thought, maybe if we colorize those body types, they would be more colorful, more eye-catchy for users, so they would click it more often. So they ran CANARY tests, where some users were seeing the shades of gray and some were seeing the colorized version. And what do you think? Which version won? Colorized. So actually, this test is still going on. And you can find for yourself in which test group you are in by going on your smartphones, even now to Amazon.com, I guess it's /vehicles, and checking if you are seeing the shades of gray or colorized version. Now, the next aspect of assuring quality of production system is chaos engineering. So chaos engineering, the idea behind chaos engineering is to ensure your high availability of your production system, production infrastructure, by actually injecting failures to this production infrastructure. And there are many companies practicing chaos testing, chaos engineering, but definitely the one that has been the most vocal about it is Netflix. Netflix has even released a whole set of tools dedicated to chaos testing, which is known as CANARY, and it's partly available on GitHub. And best known members of CANARY is Chaos Monkey. Now, Netflix infrastructure is on AWS cloud. And the purpose of Chaos Monkey is to randomly shut down or reboot servers, production servers. The tool is pretty straightforward. It's a simple script. You put it on a server, you define how often would you let Chaos Monkey to restart random production servers, and you run it. Now the question should be, which sane person would let some crazy-ass monkey to restart random production servers? So every infrastructure team has some kind of recovery procedures, and in case of unexpected server failure, it can be, for example, whether the server went up, whether the application has started, whether the application, for example, registered to some kind of discovery service, and if all the health checks are green again. And this procedure will be, of course, fully automated. Now, as you already know, production environment and production infrastructure is always somehow different than test infrastructure and test environments. And the purpose of chaos engineering is that we don't want to wait for an unexpected failure to test our recovery procedures in production environment. We want to cause this failure intentionally in the time that is convenient for us, then test our recovery procedure, improve it, fix it, so we can be calm and ready where the actual failure will happen. So the other very interesting member of CANARY is Chaos Kong. So as we already said, Netflix uses AWS cloud. And AWS offers several data centers that are spread all around the world. And Netflix also uses those data centers. So that, for example, users from Hong Kong don't have to send requests to the other part of the world, to the data center located in California, if they want to watch some movies. Now, the purpose of Chaos Kong is to simulate the unavailability of the whole data center. And as you may expect, the unavailability of the whole data center is extremely rare case. So why even bother about such a rare case? Well, it's rare, but unfortunately for Netflix, it did happen. In 2012, in December, actually right in the Christmas Eve, the flood in Oregon caused the partial unavailability of one of the US data centers. And in the result, Netflix was unavailable during Christmas Eve for some people in the United States. And as you may expect, the Christmas Eve is a peak time for Netflix, because we all just want to hang out with our families, eat well, and then just lay overeaten and watch some movies, right? So this was a big problem for Netflix. And they wanted to prevent this kind of problems in future, so ChaosConc was created. And now what ChaosConc does, it's firstly, it simulates the unavailability of the data center, and then it checks whether the traffic was correctly rerouted to the closest operational data center. This whole concept of chaos engineering is extremely important, especially for distributed architecture. First of all, remember that, again, your production infrastructure is always somehow different than test infrastructure. But also, distributed architecture means distributed infrastructure. And with distributed infrastructure, you have even more parts of your infrastructure that are likely to fail, and they're likely to fail independently. So it's very important to ensure the high availability and quality of our production system and check and test our recovery procedures. So let's discuss test automation right now. And test automation actually is quite a tricky subject because it's usually considered as something we should do extensively, the more the better. But hey, not in production environment. So how about test automation done actually in production environment? So first of all, we have smoke suites. And you may know smoke suites. There are small suites of crucial tests that cover the core features from the business point of view, usually, of our system. And they are executed just before the release on the code that is soon to be deployed to production environment to ensure whether this new release, every core feature of our system is still operational. But we already know that production environment is always somehow different than test environment. So in this approach, we want to execute smoke test suites just after the release in production environment to ensure whether just after this new release, every core feature of our system is still operational. The next aspect of test automation done in production is synthetic monitoring, and it's extremely interesting part of it. So what is synthetic monitoring? Let's say you need a certain business metric of your system in production environment, but unfortunately in production environment, this certain metric is not in the constant throughput. So you create automated tests that scenario of this test cover this feature. And then the results of these tests serves you as this constant, reliable, and synthetic metric. And we faced similar issue in Allegro, in the company I work in, while we were creating a new login form. So we were having this new login form already in production environment, but it wasn't getting any production traffic. So all the traffic was going to the old login form. And we wanted to have this reliable metric, whether this new login form works or not. So we created an automated Selenium scenario that was constantly trying to log into our system. Then we exposed REST API that was serving as an assertions whether a particular Selenium scenario succeed or not. And then the results of these assertions were collected by our monitoring system and serves us as this constant, reliable metric, whether our new login form is actually working or not. And if it wasn't working, we are getting PagerDuty alerts. So I'd like to make a little pause here as we are talking about production monitoring. Because actually this production monitoring, I think, is the crucial part of assuring quality from production environment. Only by going through production logs, metrics, some rates from production, you can learn what your users are actually doing with your system. Only by going through those metrics, those logs, you can learn how to reproduce some things, or you can learn of your system quality. So this continuous monitoring of production environment is actually the foundation for testing and assuring quality from production environment. So there's one quite tricky part missing here, and this is the performance testing of your production environment. And this is the tricky subject, because on the one hand, production environment is the last environment where you should run your performance tests. Because the last thing you want to do is run such a heavy load on your system under test in production environment so that it's overloaded and it's becoming unavailable for your end production users. But on the other hand, production is the only environment where running performance tests actually makes sense. Because production environment is always somehow different than test environments. Production environment has far more number of servers, has far efficient servers, and it can have almost completely different configuration of your infrastructure. And it's not much sense in running performance tests in an environment that has lower performance almost by definition, which is test environment. And we have some solutions to deal with this problem, of course. You can have, for example, some dedicated environment, and that configuration almost mirrors production environment in terms of infrastructure. Or you can run your performance tests in production environment, but on the services that are isolated for the public traffic. But there are some other solutions, and you can, for example, use here the CANARY approach, which we already discussed. And this is the approach that, for example, Twitter is using. So that really is the same. You're having current stable version of your application in production environment, and you have this new experimental version. So you keep both those versions in production environment, and then you route some portion of the traffic, and in case of Twitter is up to 50% to this new experimental version, and you keep the rest of the traffic to this current stable version. And then by going through metrics such as latency, throughput, response code rates, you are assuring whether with this new experimental version, the performance results are at least as good as with the prior version. So as I'm getting to the end of my talk, I'd like to summarize some things for you. And first of all, and the most important, testing production doesn't mean you are not testing before production. Testing in production means you are exceeding your quality assurance process and you are including production environment in this process. So testing in production means you are testing also in production. The next thing is our ultimate goal of all our efforts during every stage of development process is to deliver some features to production. So guess what? Only from production environment you can learn whether your system actually works and whether it's in high quality. So production is this ultimate source of feedback. The next thing is distributed architecture means distributed infrastructure. So you have more parts of your system that are likely to fail independently, and they will fail eventually. So it's very important to test your recovery procedures, improve them, so you can be calm and ready when the actual failure will happen. And the last thing is that all those test suites, all those use cases repositories, all those automated testing frameworks are very important. And you should have them and you should execute them. But there are some possibilities, there are some situations that will occur only in production environment, because you cannot predict every single possible way your users will interact with your system. So production is always somehow unexpected. And this is all I wanted to say. It was a great pleasure. I'm here for a question right now, and thank you very much.
Thank you. Lukasz, one question regarding the testing in production is related to the problems that may come on the production environment. Did you suffer any problems during the testing in production? And if yes, what are the typical ones?
there's a whole set of problems. And there's a groups of them. So for example, if you take the group of testing performance in production, for example, if you're testing your service in isolation in production environment, your service is still sharing, for example, servers with some other services that are currently getting production traffic. So the problems with this service under test may cause the problems with server, and then this application is actually getting traffic from production environment can suffer from it. There are also some problems. For example, if you're running e-commerce business, you may want to produce some products that are only for testing purposes. So then it's the naming issue. So for example, you really shouldn't name them test offer, for example, because believe me, there are some folks that all they want to do for the whole day is to go to, for example, booking.com or LinkedIn or even our service and test and just search for some test offers and mess something. So yeah, there are a whole set of problems. There are grouped in different categories, but we will always have them.
Hi, Lukasz.
Hi.
This is Barış. I have a question. So in your session, you tell us that you, in a way, shift right your testing efforts also, not only shift left. My question is, when you have a process like that, so that you can shift right your testing, can it create some comfort zone on the testers so that they believe in the end they will test the product in production anyways, so that maybe they will be a little bit more relaxed while they are doing their tests, so that when the product is live, you know, it's a little bit late for detecting defects. So the fixation of those defects will be a lot higher when you compare them with early test stages. How do you overcome that situation? If it's a process in your company, for example, to, in the end, all the people know that they will do the test in production. You got my point, am I right?
Yeah.
So, yeah, this is my question.
So first of all, I don't think that it's creating some comfort zones for testers, but actually they are more assured. And for example, our testing process, like I think yours, consists of many different stages. So we are ensuring quality on many different stages. And production environment, first of all, is about isolation if you are really testing in production environment. So it's an isolation. If you're getting some defects, they can be caused by some variables that refers to this particular production infrastructure, production configuration. So you would need to check them in production environment. And it's very important to check them before you open any traffic for this production service. And secondly, if you're approaching to testing in production as getting feedback, so you already done all your quality process. You already reviewed everything, test everything, and now it's a part of getting production users' feedback. And then, yes, you may have to improve something, you may have to change something, but it's a response for the user's feedback, right? So you have to do it anyway.
Hi.
Hi.
You said that there are some cases when you have some kind of millions of possible scenarios, and it is quite interesting for me. How can we select some most critical and crucial for us, and is there any difference from regular testing approaches?
Yeah, this is actually a question I get asked a lot. So how can you really handpick all the most crucial scenarios? And unfortunately, I can answer it to it because it depends on your domain and the context of your business. But I would say the crucial scenarios are those scenarios that brings you the most money.
Okay, I have a question. So when we talk about production, it's usually something that makes us money. So we have some paid services. And in lots of cases, you have users who need to pay for stuff. For example, if it's an e-commerce site and you actually need to buy a product in order to test checkout, right? So when you want to test it, you probably need to mock your payment systems, or you want to mock stuff that gets outside to some, I don't know, banking systems and stuff. Whether it makes it, so what's the best way here? Do we want to keep it as close to what it actually is and not mock anything, or do you still end up mocking those things?
Yeah, the payments part is actually tricky if you are talking about e-commerce. For example, there are some actions that are actually non-reversible, and taking a loan, for example, in the bank. It's quite a tricky procedure, and yeah, you may use some fake doors, some mocks. That's one idea. You may go through the whole process, but there are some limitations to that, and this loaning thing is one of them. But actually, I would ask, what do you really want to test? Because usually, the payments provider is a third-party system. And usually, you do not own this system. So maybe it's a better idea to check your API contract with them, because you don't have any influence or of the stability of this third-party system and so on. So maybe you have to think of the quality of your own system, check your own procedures, and maybe do some fake doors, some mocks, and just checking the contract between you and this payments provider.
One more question from me. When do you recommend to shift to the testing in production environment? Is it related to the number of users or the size of the system, the number of subservices, or, for example, the number of the nodes in infrastructure?
Yeah, actually, the number of users, which you mentioned, is the big part. Because imagine this. You are going through some testing phases that can last, for example, for 2 weeks. And then you push your changes to production environment, and you have those millions of users. You have few thousand requests per second. And in time of 5 minutes, they can provide you far larger number of scenarios than you go through all those 2 weeks time. So, but again, if there are some holes in your implementation, if there are some defects, then okay, everything will be open for those public traffic. So if you have that much number of users, so firstly, test your system, make it as bulletproof as you can, and then open it into this whole public traffic, and it will scale perfectly because you are getting all those different scenarios from them.
Any other questions from this side, probably? No? Okay. So what should we do, Lukasz, now? What was the most interesting question, do you think, today to you?
Shall I choose only one?
Yes.
Only one of them?
Yes.
Okay. So I think you gave two very important questions. Thank you very much.
Thank you.
So thank you very much for all of you. As I said, this is my first time in Ukraine. I really enjoy it. Again, thank you very much.
Thank you, Lukasz. This is a small present for you.
Thank you.